All right, I guess we're live. So we're going to get back to talking about how to review welding documents. Kind of a conversation I was having yesterday. I'm going to rehash some of the stuff from yesterday before I dive into new material. See if anybody's going to show up. We had 10 yesterday, so maybe we can shoot for like 12, really break the curve. So in regards to reviewing welding documents, my theory is, be polite. Not that I'm afraid to get into a scrap and not, a fist fight or a physical altercation, but to disagree with somebody in their interpretation of the code or what their deliverables are in regards to, what the expectation is for a WPS and a PQR. A lot of times, though, when you're reviewing WPSs and PQRs, the person that's the author of the document that you're reviewing might not be as experienced as you are. They might have just gotten thrown into this. Maybe it's a new CWI. We've all been there, new in our careers, and wondering, what's this code stuff? So, be polite. Sometimes it's a teaching experience. You're passing on some knowledge and explaining to people what you want and what you expect. That's one way to look at it. And sometimes that, if you go at it from that direction and explain stuff to people, the next time you need something from them, it's not nearly as acrimonious. But sometimes the person submitting the document might be a code guru, and you're the one that's maybe learning something from them. So, this is something we need to keep in mind. Yesterday I covered shall, should, and may. Shall is, the empire's here, you got no choice. The stormtroopers are coming to get you, you got no choice. Mandatory unless specifically modified in the contract documents by the engineer. So, shall. And these are the words that I use, when I'm trying to explain something to somebody. Shall. Should. And that's, should. Should means, hey, this is a good idea. This is setting you up for success. Should means it's a good idea, but if you can't do it or you have a better option, you can go that direction. Should is just a best practice and a pretty good ticket to success. So that's what we're talking about with should. It's not mandatory, but it's a really, really good idea because they listed it in the code. May is optional. You may do this, you may do that, you could do this. May is the complete other end of the spectrum than shall. So, those optional procedures that require the engineer's approval shall either be specified in the contract documents or require the engineer's approval. The contractor may use any option without the engineer's approval when the code does not specify that the engineer's approval shall be required. So the engineer's got a lot of play in this too, in regards to the codes, what you can and can't do. If the engineer says, no, you're not going to do this, then that's pretty much the end of the discussion there. So that's where we got me. And then I also discussed, and we'll keep coming back to this one, the review form. I like to have a review form. And the review form I generally use is one that I made up, but we went through this yesterday and we're talking about it. This is a grown-up way of communicating with the person that the organization that you're reviewing their documentation. Instead of just circling a bunch of stuff on their WPS and throwing it back to them like you're a 5th grade teacher and telling them to fix it, you explain to them, all right, this is a little more work than just circling things, but if you do it like this, once you do one or two of them, the same code mistakes are going to pop up over and over. Once you get one of these sheets made up, it's just duplication. So you know, you can go at it this direction, or maybe, there's some other directions, but I really prefer a sheet. And we talked about, the documents that were reviewed and where to put things on these ones. The document disposition, accepted, not accepted. Different companies have different ways that they address this. There might be 4 choices or 5 or just 3. But this is what I use on the review form. Does anybody have any questions? If you have questions, you can lob them in here too. Type them in. I'll try and look at them and see. So let's get into how to review a WPS. See if I can dive into this one. And I'm gonna kind of do a little review of, what documents, where they're at. Parts of a welding program. So for parts of a welding program, we got 3 specific documents for the most part. And I don't mean, when I talk about program, I don't mean a computer program. I mean the program, like a football program or something like that. An organizational setup, a program, welding program. So we've got a welding procedure specification, a procedure qualification record, and a welding performance qualification. Those are the 3 main tools of documentation that we use to show people that we have we have grown-ups in charge of the welding we're doing. That's what separates somebody welding a dumpster from somebody doing pressure vessels. And nothing against our brothers in the materials joining field that are out there building dumpsters, but I'm just saying, this is, the main parts here. So the PQR supports the WPS. One PQR can support one WPS. This isn't a one-to-one relationship. This is a one can support. A PQR is much like a driver's license, and it would support a WPS I'm going to back up. A PQR is like a birth certificate, and it would support a WPS much like a birth certificate would support a driver's license. You can't get a driver's license without a birth certificate. So, or a passport without a birth certificate. A PQR is the same way. It's a base document that we use to support other documentation. So we've got the PQR that supports the WPS, but we can have one PQR that supports multiple WPSs. And this is due to, I'm losing it. If you had a situation where you had multiple PQR or WPSs or multiple companies that used a similar WPS. I used to work for a company that had about 30 of the same 7018 WPSs. But the thing was, there might be small things on those WPSs that were different for each customer. So instead of revising it one time and then having to get it reviewed by company A, company B, we just had very specific. But they all went back to the same PQR. Or you could have multiple PQRs support a WPS. That's, you could have that going on. Where, you have, 3 or 4 different PQRs. One's the first one that you did, the original. Then maybe you did it with post-weld heat treat and you added another PQR. And then you went and you added another PQR for impact testing and then another one for corrosion testing or whatever. So you could have multiple PQRs supporting in the WPS. Or, maybe you had a TIG procedure, a flux core procedure, and a sub-arc procedure, and you rolled them all into one to write one massive WPS. So you could go that way. Then we got the pre-qualified WPS. The pre-qualified WPS doesn't have any supporting documentation for it. It's just a recipe. You check some boxes and make sure that you address all the essential variables in the code, such as AWS D1.1, and that's how you end up with a pre-qualified. But this is just generally for metals that we've welded a million times, such as, you know, A36 carbon steel to A36 carbon steel using 7018. The code realizes, the people that write that realize if you follow all these steps, you're not going to get into trouble. Use these groove designs, life's good. All right, so another thing we need to remember is that there's a wall. There's a wall between procedures, WPSs and PQRs, and personnel. So we don't want to mix and match. So when you're reviewing documentation, you need to realize the WPSs and PQRs are on one side of this wall, and then personnel qualifications, welder qualifications, are on the other side of the wall. You don't mix and match these, because you're going to confuse yourself and get into all kinds of trouble. So you need to realize, you know, this is how the codes are set up. So in welder qualification, a welder qualifies to a process. The welder doesn't qualify to a specific procedure. A welder qualifies to a process. And generally there's only 5 or 6 essential variables for a welding process for personnel qualifications. So that's, you know, one of the things we need to understand. It's not nearly as restrictive as procedure qualification. So we already talked about yesterday, we talked about what is a WPS. A WPS is basically a recipe. It's telling us how to bake chocolate chip cookies. That's what it's telling us. If the WPS says that we need to stand on our head and drink a Dr. Pepper while welding, that's what we need to do. That is not optional. A WPS is a work instruction, is what it is. And as such, a lot of times we need to review those. And I'm going to switch over here for another, see if I can find that other one. Does it make sense? All right. So a lot of this stuff, you know, when you're reviewing a WPS, you got to ask yourself, does it make sense? You know, does this make sense how we're doing this? You know, like if you look at the groove weld, and they have a super wide, you know, root gap that's 2 inches wide. You got to question that. Does that make sense? Why are they doing this? You know, did they qualify it this way? What's the idea behind this? If they qualified it and that's their joint design, but sometimes you generally have to ask, does this make sense? You know, makes a little more sense if you're at, you know, 1/8 to 3/16 of an inch, but it could depend on what kind of weld you're making or what your joint looks like. So, and then, you know, when we get into electrodes and, you know, filler materials and amperages and voltage, you have to ask yourself, does it make sense? What do they have listed there? You know, for 332 6010, generally we run that from 40 to 85 amps. On their WPS, would it make sense if they were running it at 300 amps? Probably not. So these are things we need to keep in mind when we're reviewing WPSs, is does it make sense? So, all right, we're going to flip back here from does it make sense to format. Don't freak out. The formatting doesn't matter. They have most codes have a recommended format, but if somebody turns in something that's a little different than what you are used to seeing, as long as they address everything, don't freak out on the formatting. And here's a standard WPS, you know, ASME Section 9 and what it should look like. Should, and I say that in air quotes, should look like because of the WPS, uh, the standard format, the standard suggested format for this. This is what the American Society of Mechanical Engineers offers up. So my general methodology is I like to try and give it a quick check. You know, before I start reading the WPS too thoroughly, I like to just give it a quick check and make sure the correct company's there, WPS and supporting PQRs are there, or did they send me the correct code? Because before I dig into this, I want to make sure that the code matches up with what the work that is being done. So, you know, the welding process, the base metals, you know, what do we got going on? If they submitted a WPS that has submerged arc welding and the project is, you know, sheet metal, does that make sense? Probably doesn't make much sense. So you kind of got to look at these and, you know, give them a quick once over before you really dive into it and you start reviewing this and you realize, oh man, I got an hour into this document and there's no way they're going to use this WPS on the project. You know, and I discussed this yesterday. Did the submitting party submit the correct documents with the right code and PQR for what the work's being done? Did they submit a sheet metal welding procedure for AWS D1.1 work or vice versa? You know, we need to, or a stainless steel procedure for work that's structural steel. You need to look at these things and, you know, make sure that everything's matches up. Another one is you want to make sure that there's no, what do you call it? Client requirements. When I worked out at the Hanford nuclear site, one of our requirements was that one of the requirements is that you couldn't use 7024 electrodes on any of the structural steel. It all had to be low hydrogen electrodes. So that's something to think about. Yeah, you could submit a welding procedure and it would be all well and good to the code, but our specification would have kicked it back. So these are things you need to also realize. Be familiar with the project specifications and customer specifications. So one of the things I do is I start looking at I'm going to correct this slide too while we're digging our way through here. Make sure the company's right, who's it welded by, what's the dates, the revisions. So just this upper part is just the general information on a WPS. Make sure that they've got, shielded metal arc, it's manual. Those are variables that need to be addressed. And then working our way down the WPS, we're going to look at, the weld joint. They don't have to list the weld joint on the WPS as long as they are addressing it somewhere. They could kick it over to a drawing. Sketches and production welds and symbols. You could say follow the drawing, whatever. Weld symbol or weld joint clarification is on the drawing or on another document. So that is perfectly legal to do if they're going to do that. It just needs to be addressed. That's a non-essential variable. Where's my other slides? I probably got some of these kind of backwards. I guess I should back these up a little bit. So, okay, so let's look at, I'm trying to work this out. You guys are kind of the guinea pigs. So one of the things that we need to look at is essential and non-essential variables. Essential and non-essential variables, that's something that we need to address on every WPS and PQR. Essential variables are WPS and PQR. Essential and non-essential are on every WPS. I'm losing it today, guys. My apologies. So, if we go into ASME Section 9, they've got tables for every welding process. And for this one, for shielded metal arc welding, stick welding, here's our table. So you can go through and say, all right, what do we got to put on our WPS? Well, we've got to put all the essential variables, which we should have addressed on our PQR, and we also need to address all our non-essential variables if there's no impact testing involved. So when we're doing our little write-up on our review form, we need to make sure that all the essential and non-essential variables are addressed on the WPS. If something is missing, we write it up over on our review form. And I usually copy, I let them know, okay, address QW 4038, thickness qualified. You qualified it on thin material and you're trying to say you can weld really thick material with this. No, can't do that. I generally give a really long explanation. So this is what we're going to run off of. So I just go down through the WPS and check out all the different essential and non-essential variables and make sure they are addressed on the WPS. If it's a supplementary essential variable, that is brought into play if this is impact tested. If impact testing is called out somewhere and we're required, then we need to address all the supplementary essential variables. So if it's impact testing, you got to do essential, non-essential, and supplementary essential variables. So back to the show here. So we were talking about sketches and joint configuration. They just need to address it. They can address it on other documents. You can address it, illustrate joint design, any of that stuff. You can address it somewhere else in production drawings, routers, whatever, as long as it's addressed. Another one is you need to go through and check all these, like non-fusing retainers, what you're going to do for backing type. Is there backing? No backing? You can do yes, no. But this all falls under joint design. And these are ones that need to be addressed. And it depends on what, like I said, not every process has the same essential variables. Gas metal arc welding, well, gas is going to be an essential variable there. There is no gas in either submerged arc welding or shielded metal arc welding. So we have to understand some basics about welding. And then the other one is, okay, so now we're working our way down through base metals. So base metals, as I discussed yesterday, there's P numbers. And P numbers are groupings of material. How close is this stuff to welding like itself? It's grouping like materials, stuff that has the same weldability, general mechanical, chemical properties. This stuff is pretty much the same, but it's a different product form, or maybe there's a little more of a certain metal in there, but it's all pretty much the same, and it welds pretty much the same. So back in the day, ASME, the American Society of Mechanical Engineers, came up with P numbers. So you didn't have to qualify every material ever under the sun because you'd go broke doing it. So then they just said, all right, here's how it is. We got different groupings. So this welding procedure is P1 to P1. which is, carbon steel to carbon steel. So this would be a pretty common one. And as written, as the way this one is written, you can only weld A106 grade B carbon steel to A106. I would be careful with this specification type or grade, because as this is written, it means you can only weld this material to this material. So I don't generally put a specification type or grade when I write a WPS. So if I was reviewing this document, I would ask the author, okay, so you're only welding A106 with this, correct? Maybe they thought this was like a PQR and they dumped this A106 on there because that's what they tested with. But if you write it on as written, you're saying this is the only thing I'm ever going to weld with this. So, but if you get rid of the A106 grade B, both of those, you can weld P1 group 1 to P1 group 1 and you're good. I don't know why they tightened it up to P1 group 1s either, but and if you're dealing with weird materials that don't really fit in a P number, you can use chemical analysis or mechanical properties. On this one, it's NA'd. And then we've got our base metal thicknesses. So with base metal thicknesses, you want to go and check those against the code section and make sure, all right, this is right. Okay, the PQR was qualified on this thickness, and with that thickness, you're going to have I qualified on, let's say, a 3/4 inch piece of plate or whatever it is. I'm allowed to weld from this thickness to this thickness. So you'd have to check this against the PQR and also against the code to make sure that they had the right, base metal thickness listed here. Pipe range diameter, all. So yeah, and then no single pass greater than 1/2 inch. So these are all providing work instructions to the welder. So let's go to this one. We're back to P numbers. Here's another one where, okay, so in this one, you can see I went through and erased the specification or grade. So this would give you a little more latitude with what you were going to weld. As that other one, you're stuck with A106 grade B. That was it. So as I'm going along, I would be entering all this information into the review form. I would put it all in the review form, typing it up. And like I said, once you've done a few of these, a lot of this material is going to be the same. There's only so many things people can miss or get wrong or whatever. So a lot of this is going to be repetition if you do end up reviewing a lot of welding documentation. But once you do a few of these, save them on a flash drive or whatever. All right, I'm doing a AWS D1.1, pull it up, change the PO number, the date, whatever, and go from there. But it's not, that's my, a lot of this stuff is just repetition. And once you've done it a bunch, it kind of just becomes repetition and repeating. And then here we've got F numbers. So this one was qualified with 6010, 7010, and 7018. So it's giving you the F numbers. So F numbers in ASME it's the filler metal type. So F1 is like E7024, your standard issue jet rod where you just crank it up and puke it in there. F2 would be something like a 6013, like a sheet metal rod. 6010 is a fast freeze, pipe liner kind of open root material. And then 7018 would be F4. So here it's given us the materials, the F number and the A number. The A number is the chemistry. So you could have filler materials that have the same F number but different chemistries, depending on what they put in there. So without looking at it, if I had you know, a garden variety E7018, that's probably going to be an A1. And I'm not looking at the chart so right now. But let's say I had a E9018C3, if there is such a thing. Well, that's probably got a bunch of chrome and nickel and whatever else in there. So it's got the coding is the same, and it's got the same F number, but the A number's different. So you've got a different A number. So this is something you got to watch out for. You need to check those A numbers for chemistry, the as deposited weld chemistry. And there's a chart in AWS or ASME section 9 that gives you the A numbers. Filler metal size, that's just given direction for ASME. That's just given direction for the welder. And I'm just doing ASME this go around. So there's some subtle differences to AWS D1.1 and how they do qualifications. But I'm just kind of giving you the general overview on how to review a WPS without getting super in detail into it. But as I'm going through this, if I find something that's a discrepancy, I'm just dumping it back into my review form. Need to drink water there. So another thing you want to look at is positions. Post-weld heat treat and electrical characteristics. So for positions, you know, you got to know a little bit about welding here. But if they had 7024 listed on the front page, if they had 7024 listed on the front page of their WPS, and then they're using all positions, well, that's not going to work because you can't run 7018 out of position. So some of these things you have to have a little bit of knowledge and understand the welding processes. As far as, where is it on here? We'll get to it down here below. So post-weld heat treat, I'm a big proponent of none. I think they came out with a code case interpretation where they said none and NA are pretty much the same. So I go with none. Some people use NA. I'm a big proponent of none because I got beat up on it a bunch when I was working out at Hanford. So I'm a big proponent of putting none. If that that essential or non-essential variable isn't used, I usually throw in none when I write them. But I guess I have to be a little more reasonable. So, and then when you get to preheat and interpass temperature, a lot of times here it's if they don't have. You got to look at the materials, but you got to look, does this make sense? You know, a maximum interpass temperature of 1,000 degrees. Well, does that make sense? Probably not. Or preheat, minimum preheat temperature. A lot of the minimum preheat temperature goes back to the code of construction and the thickness of the material that you're going to be welding. So for ASME Section 9, you might have to ask them, hey, what welding code are you welding this to? You say you're going to be welding 3-inch thick material and you got 50 degree minimum preheat, that something ain't matching up here. So you need to, sometimes you get sucked into other codes because ASME Section 9 doesn't tell you a lot about do's and don'ts. Thou shalt not do this. It just kind of lets you qualify it. And then you got to act like a grown-up at some point down the road and use engineering judgment and construct whatever it is you're constructing. So that's something you need to keep track of is when, like preheat and interpass temperatures. And a lot of that gets back to the code of construction. Are you using Section 1 or B31.1, B31.3, B31 whatever? Here I've got gases circled. That's one you need to look at when you're doing shield or gas metal arc welding. Electrical characteristics, it needs to be addressed. And depending on which code you're using and what, the situation is, you need to address it. But I don't have it from memory on whether or not they're essential or non-essential, but they need to be addressed. So yes, they're non-essential. One of the ones you need to look at is down here we've got mode of metal transfer for gas metal arc welding. This one's a big one. I think I did a rant on my YouTube channel in regards to red flags with gas metal arc welding. Well, you need to check out, the mode of transfer, and you need to understand the mode of transfer and how that works. So there's 4 modes of transfer for gas metal arc welding. But if somebody puts in here spray, I'm going to use spray, but then for shielding gas, they've got carbon dioxide listed. Well, it doesn't work like that. You got to have at least 75-80% argon to be able to get spray. Or for voltage, if they're saying they're going to run spray, but the maximum voltage is 20 volts, I don't know how you're getting there. So there's a couple of subtleties that you need to know about gas metal arc welding if you're going to, do the mode of transfer. That's kind of a tricky one and I'd say if you're reviewing anything that's gas metal arc welding, you probably should educate yourself on modes of metal transfer, shielding gas, and voltage, and to see how that goes. Okay, how to judge a WPS of duplex stainless steel. Okay, Mr. Zahir, what do you want to really know about duplex stainless steel WPSs? Oh, all right, I'll wait for an answer to come back on that one. Electrical characteristics, like I said, for the most part, these don't get too crazy. But when you get into gas metal arc welding, this is where it gets kind of weird. And you have to really understand the modes of transfer and what's going on there. Electrical wire feed, speed, range, all this stuff can be addressed. Let's see, where are we at? We get down to, okay, so then we get down to technique. Most of these things are non-essential. So you just need to be, cognizant. I've hit people a lot on, I cut my teeth in the nuclear industry, so I'm kind of picky, and that's where I started reviewing WPSs, so everything had to be perfect. So I learned that way, so I don't cut a lot of people slack. So I just go over it and then address it. And then the string or weave, is it a weave or a string? You can say both. It's addressed. Orifice or cup size, if this is a shielded metal arc welding one, we're not going to use the orifice or cup size, so it's not applicable. But if you were using a process where there was an orifice or gas cup size, list it. Pick some sizes, a range between this and this that you're going to use, and go for it. When you're writing them, you kind of gotta, does this make sense? Power grinding and brushing, all this stuff just needs to be addressed. Oscillation, none. Contact to diff, you just need to address it. And then once again, if you're reviewing it, you have to understand what they're writing and be like, okay, does this make sense? Or, all right, they've addressed it, I'm going to let it go. The last one down here is our filler metals, travel speeds, amperage range, voltage range, just our general technique in regards to weld layers and whatnot. So this is information that a lot of times it might be somewhere else. So I try and make sure that everything matches up with these and doesn't make sense. You know, if they've got on here for their 332 electrode, they're going to run it at 500 amps. I'm going to ask some questions like, what the hell are you guys thinking? But for the most part, you know, this one, all right, makes sense. Nothing's too out of line. But that's kind of some of the general techniques when you're reviewing a WPS. It's like you're looking at it, you're checking it against the code, but you're also checking, hey, does this thing make sense? So, you know, does it make sense? All right, and I guess that kind of covers it. Other than getting back to, you know, our review form, and then you're gonna wrapping it up. You're gonna on your review form, you're gonna any discrepancies you found in your WPS, you're just gonna write them down here in your review form, and send it back to your customer. So, has anybody got any questions? I guess as far as duplex stainless steel WPSs that I have reviewed, I generally, those things can get messy, so you just got to dig into them and make sure they address all the essential, non-essential variables, the customer requirements. Usually there's a bunch of customer requirements in regards to metallurgy and the heat affected zone and G48 testing and material like that, or I guess variables like that. So that's as far as the duplex stainless steels. They're just messy and long. Generally a duplex stainless steel WPS is like 50 pages or something because everything is usually put in there. So, hey, hello to the people of Colombia. So, well, and anybody else out there, hello to everybody else across the world. I don't know what time or where everybody's listening from, but hola, mi amigo. ¿Cómo está? ¿Todos muy bien en Colombia? That's my Spanish. I can kind of get around in Spanish, construction Spanish. But so that's kind of how I review WPSs and my general thoughts on how to do them. If anybody's got any questions, you can email me at, track me down at there's my email address. I answer questions all the time about WPSs, PQRs, or maybe somebody's got a welding question and asks, hey, does this make sense? So, but yeah, that's about all I got for tonight's adventure. If you guys have anything you want me to address in the future, I might do this one again. This was kind of a test run. I'm going to probably do another short one on review of welder qualifications, and I haven't gotten that PowerPoint built yet, so I'm going to have to spend a day doing that. But we'll go over a review of welder qualifications, and I'll try and point out some of the differences between reviewing a welder qualification and reviewing a procedure qualification. A welder qualification is a lot less in depth. Okay, so, all right, Mr. Picard, advice for foreign steel grades to U.S. steel grades, maybe establishing equivalent to U.S. grades or AWS groupings. Oh, yeah, that, well, my dealings with that EN 355J, I think that's a Chinese material, but my advice for that is, you're using this, that's all you can use. Sometimes it's just by the heat and lot number. What is this material? Because a lot of times, EN, European, I'm losing it, my bad. I was thinking there's a Chinese grade of steel that it's got like 3 chemistries on it, where you have like, what do you call it? It's like this much carbon, and it can't have over this much sulfur, and that's it. So everything else could be lumped in there. As far as the European grades, I just usually look and see what it's close to, but if it's unlisted, it's unlisted, and you kind of got to play that game. And it probably welds like a P1 material, but if there's no documentation where you can't get it dual certified, you're kind of stuck with it being an unlisted material, and that's kind of a tough way to go. I thought you were asking about, I saw that 355, and I was thinking about that. I used to work in they'd always try and use this Chinese steel and say, oh, it's a P1 material, and it's like, it could be, but you could also have a bunch of other crud in there floating around, and it's stainless steel. They don't have very tight tolerances on some of the steels. So, but yeah, that's how I would treat it, just as unlisted, and go with that. And there's not a lot of other things you can do with that. So, has anybody else got any other questions? Anybody got an idea for another one of these? Garry ranting about welding to 10 people on the internet. So, but no, if you guys got something that you want me to talk about, don't be afraid to shoot me a email. I got a bunch of slides. I could put something together, and I generally like to talk about welding. So maybe I'll start doing this a little more, the freelance style. So, but all right, I'm going to get out of here for now. If nobody's got any other, transfer modes. All right. What do you want to know about transfer modes, Robert? Or do you want me to cover that in a later rant? I think I have a YouTube video that covers transfer modes pretty well, but I can cover that live if you guys want. Maybe I'll do that. I'll have to write that one down. Cover transfer modes. Okay, so I'll give you the quick rundown of transfer modes. Okay, so the things that that cause the conditions to change is the gas and the electrical. So for anything with carbon dioxide up to 75 or 80%, it's just going to be short circuiting. It's going to be short circuiting up until about 20 volts, and that's going to switch over into globular. And then you've got, no matter how much voltage you add after that, it's just going to be globular. If you've got less than 75, 80% carbon dioxide, it's going to just be globular. You can do short circuiting and globular. Let me see what I got in here. Yep, there it is. All right, let's go through transfer modes. I got a PowerPoint for everything, I'm telling you. I've been kind of messing with this stuff for 5 years, so I got a lot of different All right, so we got 4 transfer modes: short circuiting, globular, spray, and pulse spray. So short circuiting is less than 20.5 volts. You can do out of position welding with it. You're going to get cold lap and lack of penetration if you don't know what you're doing. Spray transfer is over here on the other end. Yes, Robert, you can tell transfer modes by sound. Yes, I had some questions made up for my students. I can tell the transfer modes by the sound, and I can't. You're going to have to go online and do a Google search for a couple different. What do you call it? Well, do I have those? Oh yeah, let's see. Let me know if you can hear this. No, I don't have them. I thought I had slides on here with the sounds. But voltage, let's go back. Okay, so as you're moving from left to right, you're going to start with low voltage. Globular is more voltage. Spray is even more voltage. But this only happens if you got 75 or 80%. If 75 to 80% is the minimum amount of argon you can have and have spray. Anything less than that, if you got 50% carbon dioxide, you're not going to get into spray. You're going to stop right here at globular. And globular, low current density, like I said, spray, you need 80% argon for spray transfer to happen. And you need a higher voltage. Anything above about 20 volts, depending on what your, and this plays into amperage too, but for me, I always go by voltage. About 20 volts, and depending on what your size of your wire is too. That's going to play into it. I wish I had that one with sounds on it. I got that one. Oh, here we go. All right. Let's see. Let me know if you guys can hear this. All right, OBS sound source. Source is audio input capture. All right, let's see if this works. I don't know. I'm still trying to figure out OBS. Yeah, I think I have this one built in. I think I built this one like this into my channel. So, oh, you did hear it. All right.
Gas metal arc welding. A-leaf school.
All right, so let's listen to short circuiting. Okay, you heard that one? That's globular. Let's see.
Next up is
and then let's see.
okay, that was
yeah, you can tell there's a big difference between the the various processes. I can hear it. I've walked by welders out in the field and heard them running flux core or running something, and it's like whoa, 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 whoa. Or they're supposed to be running spray transfer and they're running short circuiting. It's like, what are you doing? You're not running, where you're supposed to be running. So that's one of the things that you can definitely. It's definitely not a myth. So. But, all right, I'm going to get out of here and go grab some dinner, guys. Like I said, if you want to lob me an email and you got questions about codes, standards, something doesn't make sense, I generally get back to most questions relatively quickly. So, anyways, thanks for everybody. Thanks for listening, watching. I appreciate it. Muchas gracias por su paciencia con mi habilidades en español. So, everybody, thanks for listening. I appreciate it. And we'll do this again sometime. I'll post another one. And if you guys got questions, let me know. So, all right, I'm out. Take care, guys. Have a great day today.